So we have circle P, and we know that segment RS is parallel to TV, and we also know segment RT is congruent to SV. We're also given two measurements. We know arc measure SV is 120 degrees, and angle RPS is 74 degrees. Well, as always, mark your picture with your givens. Now we want to see how these givens help us in solving for our list of unknowns, whether it's arc measures or angle measurements. So by looking at our picture, a couple of things that we should notice. Here we have a central angle, RPS. That's 74 degrees. If you recall, we know the measurements of the central angles are the same as their intercepted arc. So if our angle RPS is 74, its intercepted arc RS should be 74 degrees as well. So we could label that in our picture. So if I wanted to find arc measure RSV, outlined here in blue, we can see that it's made up of two individual arcs, RS and SV. So to find its length, we could add those together and we'd have our value. Well, our total should be 194 degrees. Now we want to focus on finding the measurement for arc RT. Well, if we look, RT, here's the arc that we're looking for. We know that segment RT is the same as segment SV. Those represent chords for our circle. And if recall, when chords are congruent, then their intercepted arcs are congruent to each other. So if we know the measurement of one arc, we can have it apply to its congruent piece. So that also should be 120 degrees. So now we want to work on trying to find the measurement for angle RVT. And if we notice, the vertex is on our circle, so this is an inscribed angle. The intercepted arc that goes with this angle is RT. And again, recall, inscribed angles are half the measurements of their intercepted arcs. So to find its measurement, we'll take half of 120, which ends up being 60. Now we want to work on finding a measurement for angle VRS. So again, we mark that in our diagram, and the vertex is on the circumference of the circle. Here's another inscribed angle. And again, an inscribed angle is half the measurement of its intercepted arc. Well, the intercepted arc here is SV, 120 degrees. Therefore, half that measurement would be 60 degrees. I want to work on finding the measurement for angle STV. So let's mark that in our diagram. Again, the vertex is on the circumference of the circle. It's an inscribed angle. Remember, the inscribed angle is half the measurement of its intercepted arc. Well, its intercepted arc is arc SV. Half of that measurement would be 60 degrees. Now we want to work on finding the measurement for arc TV. So we'll mark that. Well, remember, the arcs of the circle should have a total of 360 degrees. So if we add up the 4 arcs of our circle, that should be our total. Well, we already know 3 of those measurements, so we could solve for the length of TV by subtracting those 3 from 360. So arc TV should have a measurement of 46 degrees. Now we will work on finding the measurement for angle SVT, so we'll mark that. This angle is an inscribed angle again. The vertex is on the circumference of the circle. And remember, inscribed angles have a measurement half of their intercepted arc. Well, the arc for this angle is SRT, which is made up of 2 individual arcs, RS and RT. So if we have their total and take half the amount, that would be the measurement for our angle, which ends up being 97 degrees. We've got one more angle to calculate, angle PRS, we'll mark that. Again, this is an inscribed angle because the vertex is on the circumference of the circle, and we know it should be half of its intercepted arc. Well, if we look, we don't know the exact measurement for that intercepted arc. So is there another way we could find the measurement for that angle? Well, if we notice, that angle is part of a triangle in your circle, RPS, where we already know angle RPS is 74 degrees. And the triangle is made up of two radii. Well, we know the radii of the circle are congruent to each other. So now we have an isosceles triangle to work with. And we know in isosceles triangles, if those two legs are congruent, the base angles have to be congruent to each other because of the Hinge theorem, right? If the side lengths are equal, they have to be opened the same amount to make that happen. Well, a triangle has a total of 180 degrees. These two angles here in the triangle should be the same, and we have the other one being 74. So if I subtract 74 from 180 and take that and divide it by 2, we'll get the measurement for our angle. So our angle should have a measurement of 53 degrees.